In this video, let's learn about highest common factor. Now, I hope that you know what a common factor is. We have done a couple of videos on factors and multiples, and to understand this highest common factor, you should have a proper understanding of factors and multiples. So, if someone asks you that what are the common factors, to understand the highest common factor, you should know the common factor. And to calculate the common factor, the way will be that for 20, if someone asks you that what are the factors of 20, so you say that I can write 20 as 1 times 20, then 2 times 10, then 4 times 5, right? No other combination left? Yeah. These are the only possible ways to write 20. So you'll say that the factors of 20 are 1, 2, 4, 5, 10 and 20. These are the factors of 20. Now, what are the factors for 28? So for 28, you can write 28 as 1 times 28. You can write it as 2 times 14. You can write it as 4 times 7. No other possibility left here. That's it. So the factors of 28 are 1, 2, 4, 7, 14 and 28. Similarly for 36. So if you have to calculate for 36, we will say that for 36 we can write it as 1 times 36, then we can write it as 2 times 13, then we can write it as 3 times 12, then 4 times 9, and then 6 times 6, right? Any other combination left? Yep. That's it. And the factors of 36 will be 1, 2, 3, 4, 6, 9, 12, 13 and then 36. These are the factors of 36. Now, to find the common factor, first you find the common factor, and then as the name suggests that this is highest common factor of all these common factors that you will find, you have to choose the highest one or the greatest one. So what are the common factors of 20, 28 and 36? The common factors are, 1 is here, 1 will always be present, right, everywhere. This is one common factor. The next one is 2. 2 is here. 2 is here. The next one is 3 is present here, but 3 is not here. That's why you'll just ignore it. 4. 4 is here, 4 is here, and 4 is here. So 4 is a common factor, 4 is a common factor, and 4 is a common factor. Then 6, you don't have 6 here. You don't have 6 here. 9, you don't have 9 here. You don't have 9 here. 12, you don't have 12 here. You don't have 12 here. 13, you don't have 13, you don't have 13. 36, you don't have 36 here, you don't have 36 here. So, of all the factors, only 1, 2, and 4, these are the common factors. These are the common factors. Okay? So, these are the common factors. Now, you have to find the highest of it or the greatest of it. So the greatest of it will be, of course, number 4, because number 4 is the greatest of these. So 4 will be the highest common factor, or in short, HCF. Or we can say it as greatest common greatest common divisor, greatest common divisor. Now this is HCF of 20, 28, 36, and the 4 is the answer. Now this is one of the very basic, the basic way to tell you what exactly highest common factor is. But if you'll go through this process, then it will take a lot of time to tell the answer. So I'll discuss two more ways to find the highest common factor. So this was the first way, and it was a very basic way to explain you what exactly highest common factor is. That is, you calculate the highest common factor from common factors. Okay. So now let me remove this. I'm removing it. It's gone. Okay. Then this gone, and then this is gone. Go man, go. So this is, we are going to discuss another way to find the highest common factor, and we are going to use prime factorization in this particular way to find the highest common factor. We will use the prime factorization. Now you know that in prime factorization we factorize any number, the given numbers, in the terms of prime numbers, right? So if you have to factorize 20 in terms of prime numbers, then you can write it 20 here, and then a vertical line, and then this horizontal line, and you will start from the lowest or the smallest prime number. So starting from 2, if we divide 20 by 2, what will be the quotient? Will be 10, right? 20 and 2 is 10, and this is minus and gone. So you have a quotient 10. Then if you divide this by, is this divisible by 2? Yes. So this will be 5. The quotient will be 5. Now, is this divisible by 3? No. So the next prime number is 5. So 1. So the prime factorization of 20 will be 2 times 5. This is the prime factorization of 20. Now, what will be the prime factorization of 28? So for 28, you write 28 here, and then you will proceed in a similar way. So starting from 2, if you divide 28 by 2, the quotient will be 14. If you divide 14 by 2, the quotient will be 7. And if you divide 7 by 7, because this is the only prime number which can divide 7, so this will be 1. The prime factorization of 28 will be 2 times 7. Now, what for 36? So starting from 2, you have 18, and then you have 14, then you have, if you divide 18 by 2, you will get 9 as a quotient, and then you have 3, and then you have 1, right? So prime factorization of 36 will be 2 times 3 times 3. This is the prime factorization of 36. Prime factorization of 20 is 2 times 5. Prime factorization of 28 is 2 times 7. And prime factorization of 30 is 2 times 3 times 3. Now, is 2 common in these 3? You will say yes. You have to find the prime numbers that are common in these prime factorization of all these numbers here. So 2 is present here, 2 is present here, 2 is present here. And if you notice, then that 2 is present 2 times here, it's also present 2 times here, it's also present 2 times here, right? So you will take the maximum number of times that is common in all these numbers. Like, had it been 2 times 3 times 2, and then again 2 times 2, and 2 times 2, then you would have taken this as you would have chosen 2 times 2 times 2 from these 3, but you have only 2 times, so your highest common factor will be like this is common here, 2 times 2 here, 2 times 2 here, and 2 times 2 here. So this is common, therefore the highest common factor will be 2 times 2, that is 4. This will be the highest common factor. I'll repeat again, and I mean just let's have another example. You have 91, you have 112, you have 49. So start from 91. Write the prime factorization of 91. That is, you have to write it in the form of prime factors. So start from 91, 91 here, then start it with dividing it with, some prime numbers. Is it divisible by 2? No. Is it divisible by 3? No, because 9 plus 1 is 10 and it's not divisible by 3. Is it divisible by 4? No. By 5? Sorry, we can't do it by 4 because 4 is not a prime number. By 5? No. By 7? Yes, because if you divide 91 by 7, you'll be 7, 1, 7, then gone, left 2, and here 1, and then 3, and 21, here this is gone. So 13 is the quotient, and you'll write 13 here. Now, what about 13? 13 is itself a prime number, so it can only be divided by 13. So this is the prime factorization of 91, and you will write it in the form of 7 times 13. Now, come to 112. 112. This will be divisible by 2, yes, because it has a digit 2 at its units place. So this is 2, 5, 10, and this is 6, 56. Then if you divide 56 by 2, what will be the quotient? 28. If you divide 28 by 2, what will be the quotient? 14. If you divide 14 by 2, quotient is 7, and then if you divide it by 7, because 7 is a prime number, so it will only be divisible by itself. So prime factorization of 112 will be 2 times 2 times 2 times 2 times 7. This is the prime factorization of 112. What about 49? So if you divide 49 by, it cannot be divided by 2, it cannot be divided by 3, no, because it has, if you add these two digits, you will get 13, and 13 is not divisible by 3. By 5, no. By 6, by 7, yes, because 7 is a prime number, and this 7, and then you'll get 7 times here. Now, the prime factorization of 49 is 7 times 7. Okay, so 7 is common here, 7 is common here, and 7 is common here. Now you will say that we have 2 times 7 here, but will we take it as 7 times 7 as an HCF? No, you will not take it 7 times 7, because in this case you have only 7, you have only 1 times 7. Here also you have only 1 times 7, but here you have 2 times 7, but only 1 times 7 is common in these 3, right? So highest common factor will be 7. Why? Because only 7 is common in all these. Let's take one more example. This is 70, 105, and 175. Start from 70. So what will be the prime factorization of 70? So this is 70, and you divide it by 2, the least prime number. This will be 35, and then you have this will be divided by 5 only, because not by 3. By 5, this is 7, and then 7 and this. So prime factorization of 70 will be 2 times 5 times 7. Now come for 105. So if you do the prime factorization of 105, this will be 5, it will be divided by 3, so this is 3 and then 5. 9, yep, 50. Then you have 5 and then 7 and then 1. Now so prime factorization of 105 will be 3 times 5 times 7. This is the prime factorization. Now what for 175? So if you divide it by 3, will it be 7 plus 1 is 8 plus 5 is 13. 13 is not divisible by 3, so it will be by 5, because the next prime number is only 5, and this will be 5, 3, 15 and 5, right? So then 5, you have 7 here, and then you have 7 here. Okay, so 5 times 7, this is the prime factorization of 175. Now which prime numbers are common in these three? You will say the common are this 5 is here, this 5 is here, and this 5 is here. So 1 is 5. Which is the next common prime number? We will say 7 is here, 7 is here, 7 is here. So 5 times 7. Any other? No. So 35 will be the highest common factor. Okay, 35 will be highest common factor. Why we took 5? Because 5 is present in all these three prime factorization. And why we took 7? Because 7 is present in all these three prime factorization. So 5 and then 7, you will multiply them, and then whatever the product comes, that will be the highest common factor or the greatest common divisor. The greatest common divisor.